In this lesson, we are going to talk about tree and Venn diagrams. And just like in the previous lesson, we talked about contingency tables. The tree and the Venn diagrams are also visual representations of whatever situation it is that we're looking at to help us calculate these probabilities. And then it also helps us calculate the more complex situations when we have the conditional probabilities, when we're trying to look at just a particular subgroup of our situation. So we have Venn diagrams and tree diagrams in this section, and I'm going to start with tree diagrams. Now we have, when we're looking at probability, where we're picking something out of a bucket, or out of a deck of cards, or anything like that, we have a situation that's called with replacement or without replacement. And this example here that we're going to work on first, this is called with replacement, which means when I pick that first ball out of the urn, before I pick my second ball, I'm going to put that first ball back in. So it's like resetting the situation, and I'm starting at the beginning again, and nothing has changed. And that's why when you have something with replacement, these two events or these two picks are going to be considered independent, because when I pick the first ball and I put that ball back in, it's resetting the urn. So everything is from the way it started the first time. And that way the second event isn't affected by what happens on the first event. So when you have a with replacement situation, the events that you're talking about are going to be considered independent. Now, in this example, we have 11 balls in total in this urn, and it says 3 are red and we have 8 are blue. Here's all the information here. I'm trying to underline it for you so you can spot it. And then again, in bold here, it says we're going to do with replacement. Now, when you set up your tree diagram, I always like to start with a dot and label it start. And I like the way this book shows the different draws by shading it different colors. This strip right here with the darker purple shows this is our first draw. So when I start and I make my first draw, I could have one of two possibilities. I could pick one of 8 blue balls, or I could pick one of the 3 red balls. So they label it here. Then when I go to make my second draw, that's this lighter strip and the second set or the second layer of branches, you have more options that we're going to break this down into. Now, because I did with replacement and I put that first ball back in, we're resetting it, and now we have the same number of balls again. So if I pick, let me label this green now. If I come down this path and the first time I pick a ball, I pick a blue ball, so I'm going to come down that path on the left. When I go to pick my second ball, I'm going to again, because I did with replacement, pick one of 8 blue balls or one of 3 red balls. Now, if the first time I pick my ball, I come down this path here and I pick a red ball, again, because I put that first ball back in, I still have the same choice. I could pick one of 8 blue balls, or I could pick one of the 3 red balls. So these paths show you what all the different possibilities are. So for example, if I come down this path and then down this path that I just highlighted blue, that means my first ball, I pick a blue ball, and then my second ball, I pick a red ball. If I come down a different path, like say I come down this path here that I just labeled yellow, that means the first ball, I picked one of those 3 red balls, and then the second pick, I picked one of the 8 blue balls. So all these different paths show you the different possibilities that you could have. Because for this path right here, I pick a red ball and I pick a red ball, and there's 9 possible outcomes for that to happen. That's why it says 9 and then R, R. This means R on the first time, a red ball on the first time, and then a red ball on the second time. That's where the RR is coming from. Now this one is 24 outcomes because you take 3 times 8, but this means you take pick a red ball first and then a blue ball. That's why the R comes first and then the blue, because you pick the red and then the blue. Now on this one here, you still have the same number of outcomes, but this one here, you pick the blue ball first and then the red ball. That's why the B comes first on that one. And then this one is that you get a blue and then another blue. So that's why it's labeled BB. So whatever is on the left when you read it, going left to right, that's what happens first. Okay, so now that we see how the tree diagram was made, let me erase all my clutter here. And then we're going to use the tree diagram to answer our questions. Okay, now, because we have 64 possible outcomes of getting 2 blues, then we have 24 and 24, which is a total of 48 of getting a blue and a red, and then a 9 of getting a red and a red. There's a total number of 121 outcomes. And all I did was I just added all of those up, 64 plus 24 plus 24 plus 9. Now, the other way that you could look at it, using the multiplication rule, there's 11 balls the first pick, and then because you do with replacement and you put that first ball back in, you have 11 balls on the second pick. So this is the first pick, this is the second pick, and when you use the multiplication rule and you multiply those, you still get 121 outcomes. So there's different ways that you can total this, but make sure that whatever you're doing, you actually do find the total, because you're going to need it when you find the probabilities. I know I spent a lot of time on this first tree diagram, and I just want to make sure that you understand what it all means, so that when we go to actually use it to calculate our probabilities, it makes a lot more sense. Okay, so for part A, it says use the tree diagram to calculate the probability of getting a red and then getting another red. So RR means red on the first time, red on the second time. And we know that because of our tree diagram, there's 9 opportunities for that to happen out of a total of 121. So our probability on that is going to be 9 out of 121. And then, of course, if you want, you can put that in decimal form. That's totally up to you. Okay, using the tree diagram, we're going to calculate getting the probability of getting a red and then a blue, or a blue and then a red. So if we get a red and then a blue, we had 24 opportunities for that out of 121 for the total. Then if we look at getting a blue and then a red, we still had 24 opportunities out of 121. So when we add that up, that gives us a probability of 48 out of 121. Okay, part C says use the tree diagram to calculate the probability of getting an R on the first draw and a B on the second draw. So this is the probability. Specifically, it's telling you which draw you're collecting which color on. This is an R and then a B. So we're looking for the probability of RB, which we know is 24 out of 121. For part D, it says you want a red on the second draw and a B on the first draw. But this is using the conditional given that you get a blue on the first draw. So we're looking at just the subgroup if you get a blue on the first draw. So coming up here, looking at the subgroup of getting a blue on the first draw is right here of getting a blue. So we've narrowed it down. Instead of looking at all the branches, we're just looking at the ones that I just highlighted blue. These are the possibilities that I would get if I picked a blue on the first try. And if I take 64 and add 24 to that, that's a total of 88 possible choices. So now we want to find the probability of getting a red on the second draw if we are only looking at getting a blue on the first draw. So looking at just the options of narrowing it down of getting a red on the second draw, so that's 24 out of 88. Okay, using the tree diagram, calculate the probability of getting a blue and then another blue. if I get a blue, let me erase my clutter. If I get a blue and then I get another blue, that's this branch here. And now it doesn't say specifically given a certain condition. It just says you want blue and then you want another blue. So since it doesn't say given, we're only going to calculate this out of the total, not from a specific subgroup. So since there's 64 chances out of 121 to get a blue and then another blue, we're going to write that probability down as 64 out of 121. Now part F does that given terminology. So we're going to look at just this specific subgroup of getting an R on the first draw. So we're going to come up here. Let me erase my clutter. If we get a red on the first draw, that means we're looking at this option here. And that total, if I take 24 and 9, and I look at just that total, 24 and 9 is going to give us 33 for total if we get a red on the first draw. So that's a 33 total possibilities on that first one. Now, we're looking to see if we find the probability of getting a blue on the second draw if we have a red on the first draw. Now, getting a blue on the second draw means I am following this path. There's my red on the first draw. There's my blue on the second one. There's 24 ways to do that out of a total of 33. So when I write down my probability, that's going to be 24 out of 33. In this next example, we're going to switch things up a little bit so that you can see the difference between a couple different ways that you can make your tree diagrams. One thing that's different compared to the previous example is we're going to do this one without replacement. And what that means is when we take the marble out of the urn, we are not putting it back in. So as opposed to the previous example, when we were talking about the different colored balls, when we picked the first ball, we put that ball back in before we picked it the second time. So it's like a reset, and then we're starting from scratch again. In this example, we are not resetting, we're not putting that marble back in, so it's going to change the outcome of what could happen the second time, which means in this example, because we have without replacement, we're going to have dependent events. How we pick the first marble is going to affect the chances of what we're going to pick out the second time because the urn, what's in there, has changed. Okay, the other thing that's different compared to the previous example is in this example, we're actually listing the probabilities, you can see them here, the probabilities on the tree diagram rather than the frequencies. When we look back up here at the previous example, we listed the number of balls or what could happen, in each of those draws. This one here shows that I have 8 balls in there, and this one here, and that's blue balls, and then this one here has 3 red balls. So on this tree diagram, it's showing the frequency or the number of balls, but down here, it's actually showing the probabilities at each step. And this is my preference of how to draw a tree diagram. I think it takes a little bit more work up front to create the tree diagram, but then when you go to actually find the probabilities using the tree diagram, it makes it go by much, much faster. So this is my preference. So when we look at this, I'm going to put my little start button here. It says we have an urn and we have 3 red marbles and we have 8 blue, and that gives us a total of 11 marbles in this urn. Okay, so when we read this tree diagram, again, I like the way this book sets it up where it highlights the first and the second draw differently so you can visualize this. But when we looked at the first draw, we have 2 options. We could pick a blue marble or we could pick a red marble. Now, this is the probability right here of picking a blue the first time. The first time we pick one of these marbles out of this urn, the chances of getting a blue is 8 out of 11. And then the chances of getting a red is 3 out of 11. Those are the probabilities. Now, if I continue down, if I look at getting a blue the first time, if I look at getting a blue the second time after I've already picked a blue the first time, so now I'm looking here at the second draw. Because this is without replacement, I don't have 11 marbles in this urn anymore. I have a total of 10. So I'm going to list this down here after the second draw. What I have in there is I have 10 marbles. So that's why when you look at the second draw, everything's out of 10 now. So if I pick a blue the first time, then I no longer have 8 blue marbles in this urn. I have 7 marbles. So the probability of getting a blue the second time around, after I already picked a blue, that's 7/10. And then if you look at this total down here, what this means is what's the probability of getting a blue the first time and a blue the second time? That would be that probability. I take 11/10, which is my chance of getting it the first time, and then times 7/10, that's my chance of getting it the second time. And that gives me, when I multiply those two, because Anne tells me to multiply, I have 56 over 110. This right here, this probability tells me what's the chances of getting a blue the second time given that I picked a blue the first time. That's that probability, okay? And then we can go through the same thing on the other side. If I look at getting a blue the first time but a red the second time, because I picked a blue the first time, I still have all the red marbles in there. So I still have 3 red marbles in there. But because I took a marble out the first pick, I have 10 total marbles in there, which is why this probability is 3/10. So this probability is finding the probability that you pick a red the second time given that you picked a blue the first time. And then this probability would be the probability of getting a blue the first time and then a red the second time. Because you take 8/11ths, if I follow the track down, if I get a blue the first time, my probability is 8/10. And then I get a red, that's 3/10. And then when I multiply it together, that gives me 24/10. So I'm going to erase this to get rid of the clutter, and then we can use the tree diagram to answer the questions. Okay, so the first question says, what's the probability of getting a red and then another red? That's this right here. Because it was set up for us in the beginning, we already know that answer. That would be 6 over 110. What's the probability of getting a red on the first try and then a blue, or getting a blue on the first try and then a red? With an or statement, we want to add, so I'm going to find this probability and add it to this probability. And there's no overlap here since we're in different branches. They can't occur in the same time. You either pick, I'll show you here, let me erase. You pick a red the first time and then a blue the second time. That's this branch. And then if you look at the other probability, you pick a blue the first time and then a red the second time. That's this branch. So there's no overlap. They're in different branches. So we don't have to worry about subtracting that off. And we can just go ahead and use addition. So I'm going to take the 24 over 110. That was this one. And then add it to the BR, that probability. That was 24 over 110 for a total of 48 out of 110 for my probability of this probability right here, RB or BR. Okay, part C says, what's the probability of getting a red on the second try if you get a B or a blue on the first? Well, if you get a blue on the first try, we're looking at this branch right here. And then you get a red on the second try, we're looking at this probability right here. So this is the probability of getting a red on the second try given that you already got a blue on the first try. So that's going to be 3/10. This one here is what's the probability of getting a red on the first and a blue on the second? So since this is an and statement, we're going to use multiplication. We get red on the first times blue on the second. Now this should already be set up for us at the end. So let me just erase, but you can see the steps. If I get a red on the first and then a blue on the second, that's this path that we're taking here. So remember with and I multiply, so I take 3/11 times 8/10, and that gives me this 24 over 110. And that is because, let me write in the extra steps, that's because this is 3/11 and then this is 8/10. Okay, part E says, find the probability of getting a blue and then another blue. That would be this right here. If I follow the path, if I get a blue and then I get another blue, I end up here, 56 out of 110. Okay, and then the last example for this diagram, it says, what's the probability of getting a blue on the second if you already had a red on the first? So if I had a red on the first, if we come back up here, let me erase the clutter again. If we had a red on the first, and then we want to see what the probability is of getting a blue on the second, that would be 8/10. So to sum up what we've talked about already, we did two examples, one with and one without replacement. And then we did two different versions of the tree diagrams where we had one with the frequencies on it and then the other one with the probabilities. Okay, and this next example with the tree diagrams, this one we're going to actually draw it ourselves rather than look at the ones that were given to us in the book. So in this situation, we have a litter of kittens that are available for adoption, and there are 4 tabby kittens, so I'll label it, let's see, 4 tabby. We have 5 black. A family comes in and randomly selects 2 kittens without replacement for adoption. Okay, so we're going to have 2 picks here. So I'm going to use my start button here. Okay, so on the first try, there's a total of 9 kittens in this litter. There are 4 tabby and 5 black. I'm going to label the tabby T and the black B. So we have a chance, the first time we pick, we have a chance of picking 5 out of 9 for the black kitties. And then for the tabby, we have a chance of picking 4 out of 9. So I'm going to make it using the probabilities. So here are our probabilities for the first kitten. So let me see if I can shade this the way the book does. Let me see if I can shade it a different color on the second pick. So for the second pick, we have 2 more possible outcomes. So I could pick a black or a tabby. Now, if I've already picked a black the first time, the chances of getting a black the second time is going to be 4 out of 8. Because if we picked 1 cat out already, there's only 8 kittens left because we're doing this without replacement. And then if I've already picked a black the first time, there's only 4 left to pick. So that's a 4 in 8 chance of getting, I'll label this as a black and then another black. Now the chances of getting a tabby after I've already picked a black is going to be 4 out of 8. Since I've already picked a black the first time, I still have all the tabbies in that litter, so it's a 4 out of 8 chance. So this is the situation where I have a black, I pick a black the first time, and then a tabby the second time. Let me label this. This is the second pick. Now, if I pick a tabby the first time, then if I go to pick a black the second time, I still have all those black kittens in there, so that's going to be a 5 out of 8. So that's the case where I pick a tabby and then a black. And then if I pick a tabby after I've already picked another tabby, that chance is going to be a 3 out of 8 because I've already picked one tabby, so there's 3 left out of an 8 possible. So this is getting a tabby and then another tabby. Now, if I go down and I calculate these probabilities, let's see, I'll use green. If I come down, if I pick a black the first time, that's 5 9s. And then I pick a black the second one, that's 4 8s. So I would have to take 5 9s times 4 8s. That would give me 20 out of 72. Now, if I go down this path, where I get a black cat the first time and then a tabby the second time, that would be a 20 out of 72. If I go down this path where I get a tabby the first time and then a black the second time, that would be 4 9s times 5 8s. That would be, again, 20 out of 72. And then getting a tabby the first time and then a tabby the second time, if I multiply those together, that would be 12 out of 72. Now, when I total all of these, I should get a total of 1 or 100%. So if I take 20 over 72 plus 20 over 72 plus 20 over 72 plus 12 over 72, that gives me 72 over 72. So that's a way to check to make sure you didn't miss anything and that you calculated your probabilities correctly. Okay, now let's use our tree diagram to answer the questions. Part A says, what is the probability that both kittens are tabby? If I look at our chart, getting both kitties that are tabby would be 12 out of 72. Now, because this is an or statement, we're just going to add them. We're not worried about overlap because they're on different branches and no chance of this happening at the same time. So if we look at the chances of getting a black and then a tabby, or then getting a tabby and a black, that would just be adding up 20 over 72 plus 20 over 72, which would give us a total of 40 over 72. Now, keep in mind that I have not been reducing these. My open math might want you to reduce these, so pay attention to the directions, or you might have to put it in decimal form. I'm just going through and showing you how I'm getting these values, but I'm not spending a whole lot of time on reducing. So just be aware that you might be responsible for that. So just read the directions when you're working on your homework. Okay, part C says, what is the probability that a tabby is chosen as the second kitten when a black was chosen as the first? So I'm going to come up here and look. If I come down and follow the path, a black was picked the first time. What's the probability of getting a tabby on the second chance? That's 4 out of 8. Okay, part D says, what is the probability of choosing 2 kittens of the same color? So that means we're looking to see what's the probability of getting 2 blacks or getting 2 tabbies. So or means we're going to add. So I'm going to look at the probability of getting 2 blacks. That's 20 over 72. Plus, when I look at the probability of getting 2 tabbies, that's 12 out of 72. And so when I add that, that's going to be possible 32 out of 72. All right, now let's look at Venn diagrams. And your Venn diagrams are basically pictures that represent the outcomes of these experiments that you have. And then they generally have a rectangle or a square that's labeled as S that represents your sample space. So everything in that box should contain your sample space. And then the specific events are labeled as circles or ovals. And then the outcomes of each of those events are put in the circles. And then the and statements where there's the overlap, where they could happen in both events, you'll see that that's where the 2 circles overlap or the 2 ovals. So in this example, Lexi, it says, suppose an experiment has the outcomes of 1, 2, 3 all the way up to 12, and each outcome has an equal chance of occurring. A is going to be the set of numbers 1 through 6. B is going to be 6 through 9. So that's why 10, 11, and 12 are not in any of these circles. So 10, 11, and 12 is part of the sample space. It's one of the possible outcomes. However, it's not one of the outcomes in event A or B. So then, because in both of these events, 6 is in common, that's why 6 is where they overlap. And then A or B would be all of those items listed, but without the overlap. So I wouldn't list 6 twice. I would just list the numbers 1 through 9. So A or B would be 1, 2, 3, all the way up to 9, but I wouldn't label 6 twice. Okay, so that's a quick overview. Now, let's look at this example here. Okay, it says, flip 2 fair coins. A is the event that you get tails on the first coin, and B is the event that you get tails on the second coin. So then A could be that you get tails and then tails again, or you could get tails and heads. So all you want to make sure is that for the event A, your first toss is going to be a tail. Because you want B to be the event that you get tails on the second coin, T is going to show up in the second position in event B. So therefore, A and B is going to be just TT. That's where they overlap. They both have TT in common. And then the OR statement would be that you could have TH, TT, or HT. We're not going to list TT twice. Okay, the sample space is when you list all the possible outcomes. So here you go. So you could get heads on the first try, heads on the second try. You could get heads on the first try, tails on the second try, etc. The outcome HH is neither in A or B. Notice, because it doesn't talk about the event in A or B as getting heads in both tries. They're only talking about in these events of getting tails on the first or the second try. So when we go to draw our Venn diagram for this picture, here's our sample space. I'll label it S. We'll do A in red, and we'll do B in green. B, we said, was tails and tails, and then heads and tails. And because tails was in both events, I want to make sure I put that in where they overlap. The event A was tails, and then tails, heads. However, heads and then getting heads again is in the sample space. It's an outcome. It's just not in event A or B. So we would write it off somewhere here where it's not in one of those circles, but it still falls in that sample space. In this next example, we're going to actually draw the Venn diagram and then use the Venn diagram to answer the questions. So it says 40% of the students at a local college belong to a club and 50% work part-time. There's 5% that work part-time and belong to a club. We're going to draw a Venn diagram that shows these relationships. We're going to label C that the event that a student belongs to a club, and PT means that a student has worked part-time. So here is our entire sample space. We're going to label that S. We have C that belongs to a club, and then we'll have PT for students that work part-time. Now, it says that there's 50% of students, so all of this is going to be 50%, and it says 40%, which is all of this, and it says 40% of students belong to a club, so that's all this in red. And then where they overlap is where we have the 5%. Those are the students that work part-time and belong to a club. So I'll do that in blue because that's the overlap. This is both. They see they belong to a club and PT, and that's 5%. So here's our Venn diagram. Now, let's use this to answer some of these questions. Part A says, find the probability that a student belongs to a club. Okay, so the notation for that is P of C, and we know that that was given in the problem. That was 40%. What is the probability that a student works part-time? We were given that information too. That's P of PT is equal to 50%, which is 0.5. Part C, what is the probability that a student belongs to a club and works part-time? That's this. The probability of C and PT, that's the overlap, and that was the 5%. So we write that as 0.05. Okay, part D says, find the probability that the student belongs to a club given that the student works part-time. So this is a little bit different. We want to find the probability of C given PT. This is what we're trying to find. This one's a little bit harder, but we have all the information to figure it out. Recall that I can write the equation, the probability of C and PT. Using the multiplication rule, we would have the probability of C times the probability of PT given C, or I could write it like this, the probability of PT times the probability of C given PT. I could write it either way. What we're trying to look for here is this. So I'm going to use this equation right here. I'm going to put in my values, and then I'm going to solve for what I'm looking for. So actually, so I have some room here. I'm going to erase and rewrite this. I don't need this because I'm using the second statement. So let me rewrite it now. I'm going to use the probability that I know that C and PT can be the probability of PT times the probability of C given PT. So I know that the probability of C and PT is 0.05. We just found that above. I know the probability of PT is 0.5, that's 50%, times, and then this is what we're looking for, the probability of C given PT. So in order to solve for this, I'm just going to use my knowledge of basic algebra, and I'm going to divide both sides by 0.5. So if I take 0.05 and I divide by 0.5 so that I isolate what I'm looking for, that's going to give me a probability of 0.1. So all I did was I divided both sides by 0.5. That way I can cross these off and I'm left with this. This is what I'm looking for. In this last problem, part E for this Venn diagram, we have the probability that a student belongs to a club or works part-time. So we have the probability of club or part-time. This is what we're looking for. We know that the general rule when we're writing an or statement is we want to find the probability of the first event plus the probability of the second event, and then we subtract off the overlap, which is C and PT in this case. We have all this information and we can just put it together. I know what the probability of C is. That we figured out up here, that was 0.4. We have the probability of PT, that's 0.5. And we're going to subtract off the overlap, which is 0.05. And when we put all that together, we're going to get 0.84.